You're currently trapped in the middle of a terrifying reality. To an atom, you are a galaxy, a complex universe of empty space and energy. But to the cosmos, you're smaller than a single pixel, invisible and insignificant. We humans like to think we understand size. We don't. Today, we're going to break that illusion. We're travelling from the absolute edge of zero all the way to the largest monsters in existence to find out where the limits of reality truly begin. Before we explore the giants of the cosmos, we need to start at the smallest place reality allows. A place so tiny, so fundamentally extreme, that nothing we know can exist there. This is the Planck scale, the absolute edge of zero. If you shrink down past molecules, past atoms, past quarks themselves, you eventually reach a boundary, a limit where distance loses its meaning and space-time becomes a storm of violent quantum fluctuations. At this scale, the universe is not smooth. It foams, it vibrates, it tears and reconnects 1 trillion times every second. Physics breaks, logic breaks, even the concept of size collapses. This is the smallest anything can be. A realm we will never see directly, but one that defines the foundation of everything above it. From here, the only direction left is upward, and our journey through the true scale of the universe begins. Everything around us is made of tiny building blocks, the fundamental particles. Protons, neutrons, and electrons form the matter we can see and touch. But if you go deeper, protons and neutrons are not solid at all. They are made of quarks, held together by an invisible force called the strong interaction. Quarks themselves are strange. They cannot exist alone, only in combinations. Electrons, meanwhile, are like tiny ghosts, moving in fuzzy clouds around atomic nuclei. We can't pinpoint their exact position, only the probability of finding them. Even at this level, most of what we think of as solid matter is empty space. The universe at its core is far stranger and more mysterious than our senses suggest. Understanding these particles gives us a glimpse into the hidden structure of everything in existence. The building blocks of atoms, molecules, stars, planets, and life itself. Atoms are not tiny solid balls as we might imagine. Each atom is mostly empty space, with a dense nucleus at the centre and electrons moving in vast, invisible clouds around it. Molecules are formed when atoms connect, creating complex structures that make up everything from water to DNA. These microscopic universes are buzzing with activity. Vibrations, rotations, and chemical interactions happen constantly, unseen by our eyes. If you could shrink down even further, you would find that matter is a delicate dance of forces and probabilities, where the rules of classical physics give way to quantum mechanics. Even at this tiny scale, complexity emerges. The building blocks of life, the air we breathe, the materials we touch, all arise from these invisible micro-universes. Cells are the basic units of life, tiny worlds that contain all the machinery needed for survival. Inside each cell, molecular machines work tirelessly. Proteins fold, enzymes catalyze reactions, and organelles coordinate complex tasks. DNA, the blueprint of life, twists and folds within the nucleus, encoding the instructions for building an organism. Even within these microscopic universes, there is order, complexity, and astonishing efficiency. From the beating heart of a mitochondrion to the intricate pathways of the endoplasmic reticulum, cells are bustling cities invisible to the naked eye. Studying them reveals the delicate balance that sustains life, and reminds us that even the tiniest structures can hold immense significance. Humans occupy a peculiar place in the cosmos. We are neither infinitesimal quarks nor massive stars. We are somewhere in between. To an atom we are colossal. To a galaxy we are barely noticeable. Every step we take, every structure we build, every interaction we have exists within this middle realm. We walk on Earth's surface, a planet spinning silently in the vastness of space, surrounded by a solar system that seems immense to us, yet is itself a tiny speck in the Milky Way. Our bodies are intricate ecosystems of cells, molecules, and atoms, yet they are dwarfed by the mountains we climb and the oceans we traverse. We experience time, space, and motion in a scale that feels natural to us, but relative to the universe, it is almost incomprehensible. Understanding our place in this spectrum, between the microscopic and the cosmic, teaches us humility, perspective, and wonder. It reminds us that size is not absolute. It is relative, and our significance depends on the frame of reference. As we continue our journey from the middle-sized giants that we are, we will ascend to the colossal monsters of the cosmos, structures so vast that our minds struggle to imagine them, yet they obey the same fundamental rules that govern the tiniest particles. Beyond the human scale, the world expands into vast landscapes and planetary structures. Mountains rise like monumental sculptures, carved over millions of years by natural forces. Countries, continents, and oceans stretch across the Earth, a delicate balance of ecosystems and geology. From this perspective, human construction seems small, temporary, almost insignificant compared to the vastness around them. Stepping further back, we see Earth itself, a vibrant, dynamic planet suspended in space. Its rotation, orbit, and magnetic field form a complex system that sustains life and shapes climates. Planets are not just solid spheres, they are microcosms of geological activity, atmospheres, and chemical cycles. Even within our own solar system, the diversity and scale of planetary structures remind us of the universe's vast complexity. Understanding these macro structures bridges the gap between the human scale and the celestial, preparing us to encounter the even larger giants of the cosmos, stars, galaxies, and beyond. The solar system is vast, far more empty than our intuition suggests. The distance between planets is enormous, more space than we can easily imagine. To put it in perspective, the distance between Earth and the Moon could fit all other planets in the solar system. Even the mighty Jupiter, a true gas giant, is colossal in size. It could hold 1,300 Earths inside it. These comparisons help us grasp the true scale of our neighborhood in space. Planets are isolated islands of matter suspended in a near-infinite void. The emptiness between them reminds us that space is not densely packed. It is overwhelmingly spacious. Understanding this void prepares us for the next step of our journey, encountering stars and galaxies, the real giants of the cosmos. Stars are the true giants of the cosmos, immense furnaces of light and energy, each one a self-contained world of unimaginable scale. Our Sun, the star that sustains life on Earth, may seem colossal from our perspective, but in the grand hierarchy of stars, it is merely a modest, middle-sized example. Compared to the supergiants scattered across the galaxy, this Sun is small, almost unremarkable. Yet for us, it is everything. Consider Betelgeuse, Rigel, and Ui Scuti, stellar titans whose diameters stretch across astronomical units, so vast that if they replaced the Sun, the inner planets of our solar system would be swallowed entirely. To these stars, Earth would appear no larger than a single pixel, a fleeting speck lost within their blazing expanse. Their surfaces churn with convective currents, plasma flows, and colossal eruptions that dwarf anything humans could ever imagine. Stars are born in clouds of gas and dust, condensing under gravity until nuclear fusion ignites their cores. This process releases staggering amounts of energy, radiating light and heat across space for millions or even billions of years. Supergiants in particular live fast and die spectacularly. Their lives are violent, their deaths explosive, ending in supernova that scatter elements across the galaxy, seeding future generations of stars, planets, and eventually life itself. The sheer scale of these cosmic giants challenges our understanding of size. Distances stretch beyond comprehension, and dimensions expand to extremes that defy intuition. From Earth, a star may twinkle like a distant point of light, but in reality, it is a vast, seething sphere of nuclear fire. Observing them reminds us that the universe is not built around human perception. What seems small and faint may be a powerhouse of energy, spanning hundreds or thousands of times the diameter of the Sun. Yet even within these colossal beacons, the same laws of physics that govern atoms, molecules, and planets hold true. Gravity, electromagnetism, and nuclear forces operate on scales that connect the microscopic to the cosmic. In studying stars, we see a bridge between the infinitesimal particles at the core of matter and the immense structures that light up the galaxy. They are a testament to the extraordinary continuity of natural laws across size, energy, and time. Our journey through the cosmos, from the tiniest quarks to the largest stars, underscores a profound truth. The universe is vast, intricate, and astonishingly ordered, yet also overwhelmingly immense. Stars, with their brilliance and enormity, illuminate the depths of space and our understanding, revealing a scale that dwarfs everything familiar, including our own sun, our planet, and even ourselves. They are not merely points of light, they are cosmic giants, the true architects of the universe's grandeur, shaping galaxies, forming the elements of life, and stretching our imagination to its limits. Looking up at the night sky, each star is a reminder of the enormous scales at play. The distances are mind-boggling, the sizes almost incomprehensible, yet through the lens of science, we begin to grasp the reality. The universe is an arena of giants, where even the smallest speck like Earth is part of an immense interconnected cosmic tapestry. And as we continue onward, we prepare to witness even larger structures, galaxies, clusters, and the cosmic web itself, where the limits of human comprehension are tested like never before. As we step beyond individual stars, we enter the realm of galaxies, vast oceans of stars, gas, dust, and dark matter, bound together by gravity. Each galaxy is a universe in itself, containing billions, sometimes trillions of stars, each with its own planets, systems, and potential for life. The Milky Way, our galactic home, stretches over 100,000 light-years, a flattened spiral of hundreds of billions of stars. Within it, stars form, live, and die, cycling matter and energy across the cosmic neighborhood. And yet, the Milky Way is just one among billions of galaxies scattered throughout the observable universe. Galaxies come in many forms: elegant spirals, massive ellipticals, irregular shapes, each shaped by gravity, collisions, and the invisible hand of dark matter. Some are serene, rotating gently over eons. Others are chaotic, merging and colliding in spectacular cosmic dances. The distances between galaxies are staggering. Light from the nearest galaxy, Andromeda, takes over 2 million years to reach us. Clusters of galaxies form even larger structures, webs of matter stretching across hundreds of millions of light years. These cosmic cities reveal the universe on a scale that dwarfs stars, planets, and even solar systems. Looking at galaxies, we begin to understand the immense complexity of the universe. They are not just collections of stars. They are dynamic, evolving ecosystems of matter and energy, connected through gravity and the expansion of space itself. Every star, every planet, every particle within them is part of a larger, interconnected cosmic tapestry. The oceans of stars remind us of both the grandeur and the humility of our place in the cosmos. From quarks to galaxies, the journey reveals the astonishing scales of reality and the profound laws that govern all things, no matter how small or vast. As we prepare to go even further, beyond galaxies, we approach the largest structures in existence: superclusters, cosmic filaments, and the vast cosmic web that binds the universe together in an intricate and almost incomprehensible pattern. As we move beyond superclusters and the cosmic web, we confront the full scale of the observable universe, a vast expanding bubble of space that stretches nearly 93 billion light-years across. Every galaxy, star and particle we've seen so far is just a tiny part of this immense structure. The observable universe is not the entirety of existence. It is limited by the speed of light and the age of the cosmos. Beyond it lies the unknown, regions we may never see, separated from us by distances so vast that light has not had time to reach us. This cosmic balloon contains trillions of galaxies, each with billions of stars, forming a tapestry of unimaginable complexity and scale. Space itself is stretching, carrying galaxies away from each other and revealing the universe's dynamic, evolving nature. From this vantage, Earth, our Sun, the Milky Way, even our local galaxy cluster, shrink into insignificance. The true grandeur of reality becomes clear. The universe is far larger, stranger, and more interconnected than our everyday experience can convey. Observing the observable universe is a humbling reminder of both our limitations and our curiosity. It is a window into the extreme scales of existence, where distances, sizes, and energies surpass anything familiar, and where the laws of physics orchestrate a grand cosmic symphony. As we gaze outward, we realize that every quark, planet, star, and galaxy is part of a greater whole, a universe that is vast, expanding, and astonishingly ordered, yet still full of mysteries that challenge our imagination. As we reach the final frontier of our journey, we encounter the cosmic web, the universe's vast interconnected structure. Galaxies are not scattered randomly. They are strung along immense filaments of dark matter and gas, forming a network that stretches across billions of light-years. These filaments converge at dense nodes, galaxy clusters, where the universe's matter is concentrated. Between them lie immense voids, regions almost entirely empty, emphasizing the contrast between structure and emptiness. The cosmic web reveals the universe as a living dynamic system. Gravity guides the flow of matter, shaping galaxies, clusters, and superclusters into a complex, almost neural network-like pattern. Through this lens, we can see how the smallest particles, stars, and galaxies are all part of a greater interconnected whole. Even in its emptiness, the universe hums with activity. Gas flows along filaments, fueling star formation. Galaxies collide and merge at nodes, creating spectacular bursts of energy. The cosmic web is both delicate and resilient, a testament to the underlying laws that orchestrate everything from quarks to superclusters. Observing this intricate structure is a profound reminder. The universe is not just vast, it is ordered, interconnected, and astonishingly beautiful. From the tiniest scales to the largest, all of reality is part of a single, cosmic tapestry. As our journey comes to an end, we carry with us a deeper understanding of scale, complexity, and the boundless wonders that stretch across the universe. A humbling and inspiring vision of the cosmos in its entirety. At the hearts of most galaxies lie monsters, supermassive black holes, millions to billions of times the mass of our Sun. These cosmic giants are invisible, yet their presence shapes entire galaxies, influencing the orbits of stars, the flow of gas, and even the formation of new stellar generations. Consider Sagittarius A star, the supermassive black hole at the centre of the Milky Way. It weighs over 4 million solar masses, yet fits into a region smaller than our solar system. And that is modest compared to others, like TON 618, or the black hole in the galaxy M87, whose masses reach tens of billions of suns. These giants warp space and time, creating gravitational maelstroms where nothing, not even light, can escape. Surrounding them, accretion disks of gas and dust spiral inward, heating up to incredible temperatures and emitting powerful radiation that can outshine entire galaxies. Supermassive black holes are not merely destructive forces, they are architects of cosmic evolution. Their gravity sculpts galaxies, regulates star formation, and even drives the spectacular jets that shoot matter across intergalactic space. Studying them challenges our understanding of physics. At these scales, general relativity dominates, yet quantum effects may still play a role. They are laboratories for the extreme, revealing the limits of space, time, and matter itself. From quarks to superclusters, and finally to these colossal black holes, our journey through the scales of the universe ends with the recognition that size, power, and mystery coexist in ways that stretch imagination and understanding alike. From the smallest quarks to the largest cosmic structures, our journey has revealed a profound truth. Reality is not defined by a single scale, but by layers upon layers of complexity woven together across the universe. What seems small from one perspective becomes immense from another. What appears insignificant on a cosmic canvas holds unimaginable depth on the microscopic stage. The illusion of size dissolves when we step back and see the continuum. Atoms forming molecules, molecules building cells, cells creating life, life-shaping worlds, worlds orbiting stars, stars gathering into galaxies, galaxies threading the cosmic web, and all of it governed by the same fundamental laws. As we stand at the edge of this unimaginable hierarchy, we understand that our place is neither central nor trivial. We are a bridge between extremes, observers capable of grasping both the tiniest particles and the vastness of the universe. The scales we explored are not separate realms, but interconnected expressions of the same underlying reality. And in recognizing this, the illusion of size finally breaks. What remains is a deeper sense of wonder, that within this boundless cosmos, every particle, every star, every thought, and every life is part of a single, unified tapestry, a universe both infinite in scope and intimate in its details.